Okay, good morning, everyone. Can you hear me? Can you just type in the chat if you can hear me? I need to know. Okay. Were you guys able to hear the music I was playing? Just to... Okay. So let us start. Let me share my screen. Let's go back to screens. Share the sound as well. Okay, so we are on day 5, just like that. So day 5 means week 5. Already now we're in another unit. Okay, so before we go there, let me start with the land acknowledgement. We acknowledge we are hosted on the lands of the Mississauga of the Anishinaabe, the Haudenosaunee Confederacy, and the Wendat. We also recognize the enduring presence of all First Nations, Métis, and Inuit people. Okay, as I go down to day 5, you guys should be having access to unit 2 test, sorry, unit 1 test. And it's due tonight at 11:59 p.m. You should already have access to it. So, but we're going to start unit 2 now. So I want to go through these topics today. There is a worksheet for that. And then there's a quiz for that. Okay. The quiz is also due by 11:59 p.m. So you have 2 things, the test and the quiz. Some of you guys may have already started the test. So let me get right into this so that way we can start moving along. So let's get into the lesson. First lesson of unit 2. Okay. Let me just see if you guys can see. I got to make sure that I want to view it as a student. I want to make sure everything is open for you guys to see that you're supposed to see. Okay, so it looks like it's open today. So video lesson 1, max and min, and then introduction to transformations. You guys should remember that. And then you also have worksheets. So 2 things today I'm going to go through, max and min. So let's go through some lessons here. I'll go through this first video.
Here's just a quick lesson on completing the square. So this is just designed to be a refresher lesson reminding you of the method of completing the square. So completing the square is a method that...
Okay, so the point of going through these methods, because right now you're going to get a lot of standard form equations, and in order for you to get the max and min of a standard form quadratic, right? You cannot look at the standard form quadratic and know what's the max and min, right? You need to convert it into vertex form, okay? And in order to convert to vertex form, you have to go through the process of completing the square, okay? So vertex form, as you can see, I'm trying to remember if you guys did this in grade 10. I'm not sure. Maybe you did. Did you guys touch on this in grade 10? Let me just show of hands here. Or just... Okay. So it's a little bit of review, right? So it's a little bit of review. So that's good. So we're gonna go through that. So completing the square, it looks like you have in the end you have it in vertex form. Okay. So let's go through some of this.
Explanation of why I'm doing the steps that I'm doing. Look at one of the previous lessons I posted on completing the square. This is just designed as a quick refresher on the steps to complete the square. The reason why we wanted change a quadratic from standard form to vertex form is that we can quickly pull out the vertex of the quadratic. The vertex of a quadratic that's given to you in vertex form is hk. So if we have it in vertex form, we can pull out the vertex hk, state whether.
Okay, so that's basically why we're doing it. You can pull out the vertex, which is your h and your k, and then from there, if you remember, right, when you have a vertex, I'm just drawing on the screen here, the vertex is the point where your quadratic changes direction, like it's coming down, then it goes up, or it's going like that, okay? And your vertex is always like in the point where it changed direction, and you need to find that, okay? And then you know if this would be a max, this one here would be a min. Okay, so let's continue.
Whether it's a max or a min. If A is positive, it's a min. If A is negative, it's a max. Because that if it's negative, it opens down. If it's positive, it opens up.
And welcome back to this U.S. Open office plan.
Miller just lobbed a message way over Jones's head using some technical jargon.
Oh.
Okay, so sorry about that.
In the previous, I won't explain too much, but basically, to get from standard form to vertex form, the key thing we're going to need to do is create this right here. This is a binomial squared. To create that thing in brackets squared, that binomial squared, we will have to have this right here or this right here. These are both examples of perfect square trinomials, and there is a very
Okay, so we're going through the steps of that, right? So let's get into more of the meat and potatoes example. Let's look at it. So here are the steps to completing a square, right? So when you complete a square, you have to put brackets around the first two terms, okay? And factor out the number in front of the x squared if it's possible, okay? So if I'll just write on the screen here, so you guys can kind of see what I'm talking about. So here is, and you know what? I'm not going to write y because y is in grade 9, grade 10, and grade 9. In grade 11, we get into functions. So I'm going to write it as a function, right? Function is writing it as f of x equals, I'm running out of space. Maybe I'll write it down here. F of x equals x squared plus, I'm just making up some numbers here, 4x plus, I don't know, 6. Okay, so when you have something like that, the first thing you're going to do, it says put bracket around the first two terms. So these are the first two terms, okay? And then look to see if I can factor something out of the x squared, okay, which I can't in this case. Look at the last term in the brackets, divide it by 2, and then square it. So the last term in the bracket is 4x. If I divide it by 2, that becomes 2x, or the coefficient. And then that would make it 4. Okay, and then then basically add and subtract the term behind the last term of the bracket, move the negative term outside of the bracket by multiplying it by a if it's needed, simplify the terms outside of the bracket, factor into perfect trinomial. Okay, so we have to actually go through example. There's a lot of stuff there. Let's just go through an example and so you can all see it. Okay, so here's one here. Okay, so convert the following equation to vertex form. Vertex forms looks like that. So we're gonna go for the first step. First step is gonna be bracket around the first two terms. So I'm gonna play the video and you'll see.
Create the perfect square trinomial so that when we factor it, we get this binomial squared so that we can easily pull out our vertex hk. Step 1, you put the first two terms in brackets and you leave your c value, our plus 5, off at the end outside the brackets. Next is we need to then, so you notice it already starts to look like vertex form a little bit more. But we need to create a perfect square trinomial inside these brackets so that when we factor it, we get the binomial squared. Here's the trick for creating the perfect square trinomial. We're going to add 0 in a fancy way. What we're going to do is inside the bracket.
Okay, so basically, when we are adding a number inside the bracket, we have to also subtract that number. What you just said there is like adding, it's a fancy way of adding 0. If I add +4 and a -4 inside the bracket, it's essentially I just added 0. Right? So the key is so it's a fancy way to add 0. That's the key what he's saying there. Okay? Now let's continue.
Brackets, we are going to add and subtract half of that 8 squared. So you take half of 8, square it, half of 8 is 4, 4 squared is 16. So what we're going to do is add and subtract 16 inside the brackets. I'll continue in red. So
Okay. So he's going to add 16 and subtract 16. There you go, right? And then you're going to continue with having the +5 outside. Okay. Now what you got to do is take out the -16 and take it outside the bracket. And just keep inside here the 3 terms, okay? And that's what you have the next line. You can see there, right? So x squared plus 8x plus 16. And outside -16 plus 5. So you're going to simplify the outsides. -16 plus 5, you know that's going to be, I don't know, -11. Now inside here, inside the bracket, that looks like a perfect square, right? And that's what he's going to get into right now.
Trinomial that I've created, and it's going to factor very nicely to a binomial squared if I've done things properly. I need to find 2 numbers. So when factoring a quadratic with an a value of 1, you find 2 numbers that have a product of your c value, a product of 16, and a sum of 8. The 2 numbers that multiply to 16 add.
And we know those 2 numbers, right? 2 numbers that add up to 8 would be 4 plus 4, and 2 numbers that multiply to 16 is 4 times 4. So you know, I'm going to have here x minus 4, x plus 4, and then x plus 4. Wow, okay. Well, I'll continue to play the video.
Add to 8 are 4 and 4. And that should always happen when you factor a perfect square trinomial, is you get the same number here and here. It's a number repeated that gives us our sum and product of what we're looking for. So when I put it into its factors, it would be, I'll erase this in a second, it would be y equals x plus 4 times x plus 4, with the negative 16 plus 5 off at the end. I'm not going to write
again. So now you don't write x plus 4 times x plus 4 because we're getting this in the quadratic or vertex form. You know, this is just saying the same thing as saying x plus 4 squared. Okay, that's what we just, so now we're in vertex form because all we're going to do now is write it as x plus 4 squared minus 11. And that is your vertex form. So your vertex is going to be made up of what we said there. Your vertex is going to be, the point is going to be, that's going to be -4 and -11. That will be your vertex, okay? Based on the vertex form of this equation.
So it's now in vertex form. My vertex, actually asks us for axis of symmetry as well. I'll write that first. Axis of symmetry, that's the vertical line that passes through the vertex. It's always x.
So the axis of symmetry is going to be the number, the vertical line that passes through the vertex. The vertical line passes through the vertex, crosses the x-axis, so be a -4.
Equals whatever the h value is. In this case, h is -4. Our vertex.
I need to find the best way to learn math and science.
It's brilliant.org.
What?
Is always hk. And in this case, our h is -4. Our k is -11, so the vertex is at -4, -11. Is the vertex a max or a min point? Since our a value is +1, that means the parabola opens up. which means the vertex is at the bottom of the process.
Okay, so you guys get that, right? So you know that is your vertex form. In this case, it is a min because it opens up like that, so it's a min. Okay, so let's go into another example. So here is another example, because you're gonna have to know how to do this. And you do the same steps, okay? But before, so you're gonna put a bracket around the first two terms. So I'm gonna step through this to kind of speed up the process. Bracket around the first two terms, okay? And then you add your plus 11. Okay, but then the next thing you have to do, by the way, this would be really bad of me to ask this question, but can you guys hear the video? Because this would be wrong if you guys can hear the video and I went this long. Okay, just making sure. Because the last time you guys were very quiet and didn't even say if it was wrong. Okay, thank you. So then the next thing you got to do is factor out, because in front of the x squared can't be a number inside the bracket. So that means I see a 2, I have to factor out the 2. So that means I got to factor the 2 from both of these terms. So 2 goes on the outside. I'm left with this x squared, and then I'm left with, so I divide this by 2, this becomes negative 6x. So the next line, when I fast forward, looks like that. 2's on the outside, and I'm left with, there you go. So I have 2, so that it's already kind of looking like I'm gonna get, I already know what my A is, right? For in vertex form, which is probably gonna be 2. So inside my bracket, my last term, well, what I'm gonna do is take out the 6, I'm gonna divide it by 2, and I'm gonna square it. So if I divide the negative 6 by 2, it's negative 3. When I square negative 3, it becomes 9, right? So on the outside here, after the negative 6x, I'm gonna have plus 9. It's like adding it's like a fancy way of adding 0, right? If I add 9, I also have to subtract 9. It's just like adding 0. Plus 9, subtract 9. So here we go. That's what he's showing you. It's gonna be 9. I subtract 9 because I'm gonna add 9. That's another fancy way of adding 0. Then I have plus 11 on the outside. Okay. So now I need to take out the negative term on the bracket, only be, so I'm left with 3 terms. When I take out this negative 9 out, I take it out, but I can't just take it out because it's inside this bracket. So I have to take it out and then multiply by this number 2. So when I take it out, it's going to become minus 18, not minus 9. It's going to be minus 18 outside the bracket. Okay. So when I go to the next line, I'm showing you there, I got to multiply by 2. And it looks like this now, right? So 2 on the outside, I'm left with 3 terms inside the bracket. Now I have minus 18 plus 11. Okay, so looking at this bracket, can anyone tell me what would be the answer here? This looks like a difference of square. So what would be the answer here? To look at it, you know, 2 numbers that multiply to give you plus 9. And then when you add them together, they give you minus 6. What 2 numbers are that? Anyone tell me in the chat? Minus 3, minus 3. Yes, minus 3, minus 3. Okay, so I'm going to have here now 2 in for my bracket, and I'm going to have a bracket of x minus 3 squared, because minus 3 both multiplies and adds to 6, negative 6 and 9. Okay, so we're going to fast forward that. There you go. And then you're going to have minus 18 plus 11 means minus 7. Okay, so therefore now I have my my vertex form. I know what my axis of symmetry is. My axis of symmetry is going to be 3. Well, I'll just write down what's my vertex first of all. I already know it's 3, comma, negative 7. my axis of symmetry is it's the vertical line that goes through the x component of my vertex, which is 3. So my axis of symmetry is going to be 3. My vertex is 3 minus 7. And because it's a positive A over here, that means it's going to open up. Therefore, it's going to be a min. Okay. So I'll just fast forward a little bit. Actually, clear that. And then fast forward. There you go. Your vertex is that. And he's showing you that it's a min. Okay. Because it opens up. Because my 2 is a positive number. Okay.
Point. Let's move on to this one since it has a fraction.
Okay, so this one is a little trickier. Why? Because I have a fraction here. Okay, so I'll go through this. This will be the last one, and then we'll go on to another thing. But it doesn't really. Nothing changes. The process is still the same. Okay. The only thing is it's a fraction and it's a negative number. When we see fractions, oh whoa, we get scared. You just gotta learn how to use. Just be confident in knowing how to manipulate fractions. Okay, so step doesn't change. I put a bracket around the first 2 terms. Okay, that's not going to change. There you go. Right, and I have plus 5 on the outside. Right, now I have to factor out the negative 2/3 out, and if I factor it out, negative 2/3, I also have to basically factor it out of the 8x. Okay, so that's not that easy, because what that means is for the 8x, I have to divide 8x by negative 2/3. Okay, I'm going to play the video and we'll take it from there.
Next, we factor out whatever number is in front of the x squared. So we're going to take out that negative 2/3 and divide both of the terms in the brackets by the negative 2/3. So I'm going to have to divide this 8 by the negative 2/3 that I took out. So I'm going to have to do 8 divided by negative 2/3. That's the same thing as saying 8 times 3 over negative 2, which would give me 24 over negative 2, which equals negative 12.
Okay, so that shows you it isn't that hard, right? You're just using your fraction rules, and he wrote in a way that you can see that he just dealing with fractions. If I'm dividing by a fraction, I multiply the reciprocal. That's the rule you guys learned from grade 3. And then it becomes easy, right? Then it's just negative 12 is my answer. Okay, so it's gonna be x squared plus negative 12. Okay, so the next thing is that, so I look at that negative 12, and we did what we did before, is add another fancy way of adding 0. So after that, so what we have to do is take the negative 12, divide it by 2, and square it. So negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So I'm going to have here negative 12x plus 36 minus 36. Okay, that's another way of showing a fancy 0 right there. Okay, and then the next thing we do, we have to take out that negative 36, because I'm only supposed to have 3 terms in here. If I take out that negative 36, before I take it out, I have to multiply by a negative 2/3. So on the outside here, it's going to be negative 36 times negative 2/3. So I can just say, it's like saying negative 36 times negative 2, that's 70, that's plus 72 divided by 3. 72 divided by 3, I won't do the math, you'll just show us right here. You'll see it here, right? It's 24. Okay, so when I take out that negative 36, I multiply by a negative 2/3, I'm going to get plus 24, and then plus 5. And now we just go by what we've been doing before. Okay, I'll play the rest of the video.
A bit, give us some more room. Last step, I need to factor what's in the brackets. the numbers that multiply to 36 add to negative 12 are negative 6 and negative 6. So I get x minus 6 times x minus 6, which is x minus 6 squared. 24 plus 5 is 29. My axis of symmetry, x equals 6. That's the vertical line that passes through the vertex of the quadratic. My vertex is at 629. Oops. 629.
Okay, so you get it, right? So basically my vertex is 629, and then that's how we do we go from vertex form go from standard form to vertex form. Okay, so hold on. Let's go back to the lesson. I think let's look at this video. I'm not quite sure if we need to, but I'm just gonna double check.
Okay, here's another part to the 1.3 finding the max or min of a quadratic lesson. First part of the lesson, I reviewed with you how to find the max or min using a method called completing the square. In this part of the lesson, I will teach you how to find the max or min of a quadratic using the method of partial factoring. Okay, so here's all the steps to partial factoring. If you want, you can read through them right now. Just pause the video and read them. I'll reference them as I go through the examples and explain as I go along. So here's our first example. We have a quadratic y equals x squared plus 2x minus 6. Now, of course, when you have an example like this, you're not going to have a picture of the quadratic right beside it where you could just say,
okay, so we're going to go through the same steps, but it's basically called partial factoring to find the vertex. Then we got to state the max and min. Okay, so let us go through the steps. If I go back, I'm trying to fix the screen, so give me a second. It's not allowing me. Okay, there you go. Now it's full screen. Okay, so we go back to here. Steps for partial factoring. Look at the constant term in the expression. Set y equal to the constant term. Isolate the terms of the variable. Common factor out the left side. What is left in the expression? Solve the remaining equation by x by finding the two places where x is equal to 0. Okay, so we can read through this, but you got to actually just do it. So let's just get into doing it. Okay, here we go.
Example like this, you're not going to have a picture of the quadratic right beside it where you could just simply look and pull out the vertex. But for this example, just so you understand what I'm doing, having the graphic here will make it easier for me to explain to you what's happening. So for partial factoring, it's another method to find the vertex. Some people would prefer this to completing the square. It's up to you most of the time which method you use. I'm just going to show this to you so you have more tools you can use to find the vertex of a quadratic. So here's how we use partial factoring.
So by the way, what we're showing, like he just said, it's just another method. I'm showing you this just to make sure that you get aware of it, but I would just, since you guys are probably more comfortable with completing the square, I would probably stick to completing the square, but I'm going to show you this because I have to, but you can do either way. Okay, so you know that.
This is your brain when you're struggling to focus. And this is your brain when you're in the zone. But
to find the vertex. First thing we're going to do is we are going to look at the constant term in the quadratic and set the quadratic equal to that constant term. So I will write negative 6 equals x squared plus 2x minus 6. So I've taken the constant term, set the quadratic equal to that. Now, if I were to solve this quadratic, what I would get would be the x values where the quadratic has a y value of negative 6. So if I go through algebraically and do that, I should get an x value of 0 and negative 2. Those are the two places that the quadratic has a y value of negative 6 at 0 and negative 2. After I've calculated that value of 0 and negative 2, I could use those x values and the fact that I know that quadratics are symmetrical to find the x coordinate of the vertex by finding
Okay, so the one thing to let's go back up again, okay? If I set my y equal to -6, right? What he's showing you here, and this is why he has the graph here, is that if my y is -6, right? There is, you know, your quadratic is always in symmetry, right? So if I have a -6 here, okay, when I solve for x, I'll probably have two values of x, right? My two values of x would be, because we're saying this is -6, not 0, we're saying it's -6. We're gonna have a value at 0, and we're gonna have a value at -2. And if I have those two values, I already know it's symmetrical. So that's sort of giving me the starting point of my my quadratic. Okay, that's what he's showing you there.
The average of those two x values. Once I know the x coordinate on the vertex, I could find the y coordinate by plugging in the x coordinate on the vertex into the.
Okay, so if I know this value of my x, and if I know this value of my x, so what is it? -2 and -0. Well, you remember the difference in between is the average. So if I add 0 and -2, the average would be -1. So therefore, the middle part is -1, which is the vertex value for the x component. But for me to find the y component, I plug in here -1, and then then it helps me to figure out what is the y component value. Okay. If I plug in here in the original equation -1, then I know what my y value is. Okay. It's a little bit more complicated than I think than completing the square, but I'm going to show you just to show you.
Original equation and solving for y. Now, you might ask, why did we decide to set it equal to -6? Well, you'll see it's going to end up working out nicely because when you set the quadratic equal to whatever the y-intercept is, keep in mind the c value of a quadratic in standard form is the y-intercept, you'll always get one of your answers to be 0 because it's right on the y-axis. So we're going to always set it equal to the y-intercept and then solve for what values of x have that y value. One of the x values will always be 0 because that's one of the properties of a y-intercept. Okay, so let's go ahead and actually do algebraically what I just explained here. So let me erase these. So I've set it equal to the y-intercept. Now I'm going to solve for the two x values that have that y value of -6. So step 1, I'm going to move this -6 to the other side. Of -6 plus 6 equals x squared plus 2x. So I have 0 equals x squared plus 2x. Now I need to solve this for x. So in order to solve this for x, I have to factor. So I'll common factor the right side. I can take out an x, and I get x plus 2.
Okay, it's basically solved right there. You can see it's factored out. So my x, in order to get 0, my x can be 0, or my x could be -2. So I have 0 over here on the graph, or -2. Okay. That tells me, because remember we set our y equal to -6. If our y is equal to -6, therefore our x is going to be 0 and -2. That's how you got that, right? This method, like I said, is not the preferred method, but we just got to show you that.
Now I'm going to use what's called the zero product rule. If I have two factors being multiplied together to equal 0.
Okay, he's just making it long there, but that's basically what we're saying here. Okay, so I'm not really going to go through and show you another example, because okay, let's just finish off this example first, and then we're going to go on to another video.
These are the two x values that have a y coordinate of -6. So essentially I've found 2 points on my parabola. I've found the point 0, -6, and sorry, I found the point, 0, -6, and
-2
-2.
and -6.
-6. Those are the 2 points I've found.
Okay, you see how it's a little bit cumbersome, this process, right? So I wouldn't do it, but I'm going to show you. So now we know those are the 2 points, and then in order to get the vertex, you got to average the 2 points, right? So he's going to average the two x points. So you're gonna average means you're gonna add the -2 and the 0, my 2 x points, and then your average is gonna be -1. Just gonna show you. Right, I'm just gonna, there you go, right? He's looking for the average. 0 and -2 divided by 2 gives you -1. Okay, so my vertex, the x component is being -1. So then in order for me to find the y component, I plug in y at the beginning of the equation. Right? So that's what he's gonna do. At the beginning of the equation, the top part of the equation, which is x squared. Oops, sorry, commercial time. Oh, hopefully I can skip this commercial quick.
Tired of typing tons of notes during class? There's finally a better way. It's called Otter.
Okay.
Is
Okay. So you plugged it back in the original equation and you got 7. This is now the vertex. Okay.
at -1, -7. And since my a value of the original function is +1,
So therefore my a is +1 at the original function. Therefore in the vertex form, my a value is going to be positive. Therefore, we know that it opens up, even though we have the graph in front of us, we know it opens up. Therefore, it's a min. Okay.
I know that the parabola opens up since the a value is positive, so this is a minimum point.
Okay. So like I said, I wanted to show you that, but doesn't mean that's the best way to do it. I prefer completing the square. Okay. Let's go on to, so we did those 2 videos. Let's go on to here. We're going to do transformation. And then that's the last thing, transformation. You guys were introduced to transformation last year. Do you guys remember? Anyone remember transformations from last year? Yes, no, nobody? You guys are still there? Okay. Yeah, no. Ooh, okay. Well, it was in grade 10. So here is kind of what we're showing you here. You can see, right? You got vertex, vertical stretch, compression, so this is what you're going to be doing. So let's go through this video.
I'm just introducing to you transformations of functions. We're going to look at a few different functions and transformations of those functions this unit. First function, we're going to look at the function f of x equals x squared, so a basic quadratic function. We'll apply different parameters to that function. We'll call this the parent function of quadratics and see what transformations happen when we apply different parameters to that. We'll also look at the function root x, and we'll also look at the rational function 1 over x. So we'll work with those 3, we'll call those parent functions.
Okay, so with transformations, we've done transformations in grade 10, where you did the quadratic. But transformation can also be applied to the root x and then the 1 over x, okay? So this would be a rational function, okay? So let's get into it. Fast forward. So here is the general equation for transformation, okay? So we have here, so this is, so the g of x is the transformed function of f of x, okay? So I'm gonna rewind this a little bit so we can get into the beginning. And I'm going to play the video here.
We'll call them a, k, d, and c to the equations of those parent functions. So first of all, when I'm saying transformation, what does that mean? So basically a transformation means we're either going to be shifting the function, so shifting the graph of the function either left, right, up, or down, or we're going to actually be changing the shape of the function by doing what's called vertical or horizontal stretches or compressions, or also vertical and horizontal reflections. And how we're going to do that is by looking at the parent function f of x. So like these were different parent functions we're going to work with, and we're going to apply different parameters to those parent functions. We're going to apply the parameters a, k, d, and c. And this is the general form of the equation of a transformed function. So g at x would be the equation of a transformed version of the function f at x. We'll call f at x the parent function, and we'll
Okay, so you need to understand this. This will definitely come on the next test. And so understand that. So we're gonna get into, like I said, you need to get into an example. Okay, so the transformations are in order of transformation. You've got stretches, compressions, reflections, and translation. Okay, so stretches is your A, right? Stretches and compressions are your A. And also your A can also be a reflection, because if it's a -9, it reflects. Okay, and then you have your translations, which would be your D and your C. Does it move left and right, and C moves it up and down? Okay,
look at just a basic function like this. And we'll do transformations to that before we actually look at quadratics, radical, and rational functions. So I mentioned A, K, D, and C.
And welcome back to this US Open office plan.
Miller just lobbed a message way over Jones's head.
So here's the equation of our transformed function g at x. It's equal to a times f at x with k, d, and a c in here as well. And what we're going to do is we're going to look at what exactly do these a, k, d, and c parameters do to the parent function f at x. So we'll go one at a time. We'll look at the vertical transformations first. So the vertical transformations.
okay, so vertical transformations are what makes it go up and down. So the transformations for vertical would be your A and your C. That's what he's going to show you right now.
Are going to be A and C.
Right? The A either stretches it, compresses it. Your C either moves the whole thing up and down. Okay?
And then the horizontal transformations.
Again, and then the horizontal would be your K and your D. So D moves it left and right, and then K compresses it either or stretches it horizontally or compresses it horizontally. Okay?
Are going to be caused by the K and D parameters. So let's look at A and C first. So C, that's just going to shift the.
Yeah, I'm gonna fast forward some of this stuff because some of the stuff we know from last year. C moves up and down, so we can fast forward that. Your A compresses it, so we know that from last year too, or stretches it. Okay, so if my A is greater than 1, that means it's going to stretch it. If my A is a decimal, meaning it's between 0 and 1, that means it's going to compress it. Sorry, it's going to compress it like this. I'm using my hand so you can see. So if A is positive, it stretches it. Okay. And if A is negative, if it's a decimal, when I say decimal, it's in between -1 and 1, that means it's going to compress it. Okay, and if A is a negative, if it's just a negative, then it flips it upside down, reflects it over the x-axis. Okay, so we can kind of fast forward that because that's a little bit review. So now we get into horizontal changes. Okay, translations, transformations. Okay, so the D, like we said before, it moves the whole thing left and right. If it's positive, negative. If it's positive, it goes to the right. If it's negative, it goes to the left. Okay, so we know that. And then fast forward. Okay, let's fast forward a little bit more. And oh yeah, the other thing too is you have to, I guess what he's trying to make you understand is that in the video, let me play it, because people make mistake when they see a negative. They think that negative D means it's actually a negative. No, when you see it like this is actually positive D. The equation is written that way. So he's showing you that if I have f of x, x minus 5, my D, is it negative or is it positive? I want to see if you guys are paying attention. In this case here, is my D negative or positive? Question to the group. It's positive, yes, right? Because the equation is written like that, but the actual D, which is in here, which would be 5 is actual D. That means it's positive. If it was written where, someone's trying to get in, if it was written where X plus a number, then you know that number has to be negative because the original equation is positive, or sorry, it's negative, okay? So that's what he's trying to explain there. And you guys should know this from last year too. It's not like it's something new. Okay, so let me fast forward. We have to get through this before 10. Okay, so now here's the tricky one. The horizontal stretching and compression. Okay, so why it's tricky is because you have to remember, in order to do this, the stretch and compression is based on the K being 1/K. So if I say my K is 3, okay, say my K is 3 here, just suppose it's 3. Then if my K is 3, I'm just using it as an example. If K is 3, that means my factor is 1/3. Now 1/3 is less than 1, right? If it's less than 1, you can see here. If it's less than 1, or my bad. Less than 1 is over here. Let me erase that so you guys don't get confused. This is not less than 1. Right? So this is between -1 and 1, which is still less than 1. It is a horizontal compression. Okay? I might have said that one wrong. It's not a horizontal compression. It's a stretch. Okay? Okay, my bad. I don't want to confuse you. Right? Don't want to confuse you. Right? Okay, because K here, I said K here is 3, right? So K is 3, which is greater than 1, but because 1/3 is small, you basically are compressing it horizontally. Okay? And this makes sense because look at the value. It's 1/3. It's a small value, right? It's a fraction. But because I'm taking the K and my K is greater than 1, when I plug it into this equation of 1/3, it becomes small. Therefore, I'm compressing it. Now, if I were to change it up and say, if I were to say K is, let's say I say K is 1/2. I say K is 1/2. And I go back to this equation, then I got to put K 1/2 there. 1/2 is like that. That becomes the same thing as saying 2, right? You have to be able to do that as a fraction, right? 1 divided by 1/2, right? That's what we're showing you here, right? This represents the K, but 1 divided by 1/2 turns into 2. So now 2 is now a bigger number. So my graph is going to be stretching by a factor of 2. Therefore, you can see here, if my K is a decimal, which is what I said here, which is a fraction, now I'm stretching it by a factor of 1/K. In this case, my K is 2. Okay, that's the part people get stuck on the most. And I think you guys would have, if you did this last year, you would recognize that too. Okay, so I'm going to play the video from here so we can see that part. Let me clear the screen and continue.
And if it's less than 0, so if it's a negative value, it's going to cause a horizontal.
Let's see if he talks about it further. Let's back up a little bit. So I think I skipped a lot. Okay, so we're gonna go to the beginning of the stretch compression horizontal.
K value. K is going to cause horizontal stretches or compressions. The K value also will be inside brackets but in front of the X. What's going to happen is it's going to cause, instead of a vertical stretch or compression like A, it's going to cause a horizontal stretch or compression by a factor of 1 over K. So since it's by a factor of 1 over K, when K is bigger than 1 or less than -1, that's actually going to cause a horizontal compression.
Okay, if K is bigger than -1 or 1, again, it's gonna be 1 over K. Now I have a fraction here, right? So my graph is gonna change by a factor of a fraction. Since it's a fraction, that means I'm compressing. Okay, so if K is greater than 1, I'm compressing. If K is in between -1, or I like to say a decimal or a fraction, if I put the fraction inside this equation, 1 over K, that becomes a big number. If you remember your rule in math, if I divide a small number, if I divide a number by a decimal, that means, or a fraction, that means my number, my final answer will be much bigger than the original number. So since I'm dividing it by a fraction, I'm going to get a big number. That's why I'm stretching it. Okay, I want you guys to understand that. And then obviously, if it's a negative, if K is a negative, then it reflects around the Y. Sorry, I didn't mean to do that. It reflects around the Y axis.
By 1 over the K value. If it's between -1 and 1, it's actually going to cause a horizontal stretch by 1 over K. And if it's less than 0, so if it's a negative value, it's going to cause a horizontal reflection. And when we're talking about horizontal stretches and compressions, we're talking about the points of the parent function, its distance changing by a factor of 1 over K in relation to the y-axis, so moving horizontally in relation to the y-axis. And a horizontal reflection.
Okay, so we kind of get that. Let's get into an example. So I think you need to see an example. Here we go. Here's an example right here.
What? Still searching YouTube for Canadian math help? Are the videos for US students really helpful?
Okay.
Being added to the X. So this
So if you look at this here, right? Here's an example, right? I have an example of, I guess this would be, what parameter is this, C or D? It basically is moving it to the left. It's moving this whole thing to the left, right? So it's transformation and it's going to move to the left. So let's play it out. Let's play it out. There you go. So it's D. My D is moving the whole thing. So whatever value I have now on the original function, I gotta subtract 2 from that number for the X component. So if I'm over here, I'm at -3, I subtract 2, that means I'm going further this way. So I'm right bad. -2 takes me to -3 takes me to -5. So I'm going to go this way. Okay. So each point is going to move this way. All right. So it shifts to the left, and you can see now what it looks like in the blue. Okay. It shifted that way. Okay, here's another example. This one, this is my function here. And then now I have a negative. My A is negative. That means all I'm doing is flipping it upside down about the x-axis. Okay, I'm reflecting it. Okay, vertical reflection over the x-axis. That's all you're doing. So if my point here is what is it? -3 on my X and 2, I'm going to bring it down to here. So now it's going to be, it's still going to be -2, but now it's going to be plus, my X is still -2, but my Y now is going to be a negative, right? My Y now is going to be -2. So here you go. I'm just going to fast forward so you can see what it looks like, and it's going to be in blue. There you go. See how everything just flipped? So it's still -3, but now I got my Y is -2 now. Okay. So let's go through another example. Here's another example. Okay, so what does this one do? Right? F of x, my function, this whole thing is my function f of x, but I'm shifting it by 3. I'm going to move, that means it's a +3. It's on the outside. That means the whole thing is going to move up by 3. It's going to move up by 3. Okay? So whatever value I have for my y, it's going to go up by 3. So if my y here is 2, now it's going to be 5. My y here is -3. It's going to go up 3. Okay? Then it's going to be at 0. So let's look at the answer. There you go. See, shifted up by 3. Okay, pretty simple. Let's look at another example. Oh, this one's a combo. So this one here, I have it's going to go up by it's going to go down by -1. But then I also have I have a k value, right? That's a k value because it's inside the bracket. So my k value, let me see if you guys know this without me saying anything. My k value is 2. Is this going to be a stretch or compression? And it's a k, that means it's going to be horizontal. But is it going to be a stretch or compression? You tell me. Let's see who gets this. You're paying attention. Based on 2. Anyone? Only one person is trying to guess. No one else? Okay, so let's look at it again. Oh, another answer. What did you say? Compression. Okay, so one compression, one stretch answer. Let's see here. Remember, right? So my k is equal to 2, right? The factor is always 1 over k, right? That's how you apply the factor. So if it's 1 over k, if I plug in 1 over k, I plug in 2 now. Now my answer is a decimal. So because my answer is a decimal or a fraction, it's making it small, right? So since it's making it small, it's a compression, right? If my k was, like I said, a fraction, then if I plug it in here, it becomes a big number. So now, so you know that, yeah, my k is 2, but in the equation 1 over k, it becomes a decimal. Therefore, I'm compressing it because it's a small number. Okay? That's how you guys should remember that. And so my parent function is this, right? He's plugging all the points, and then he's going to apply the factor, right? So for all my x's, he's going to multiply by 2, right? And then he's going to also, for the y's, it's going to shift. So let's just get through. Let's see here. I'll play out the video.
After the x. What we're going to have to do, well, we don't have to do this, but the easiest way to do this is when we're doing multiple transformations, is to first list out the coordinates of the points of our parent function. So the points for the parent function f at x, we have point -3, 2, point -1, -3.
So what he's doing basically, you should kind of do this, is list out what is the beginning function, which is, you know, you put all the points, all these points are these points here. Okay, that's what he's just kind of showing. That's a practice you should do. And then apply the transformation to when you have these points.
1, -2, 3, -2. So those are the...
And it's the reason why you do that, because it's not there's multiple things happening to this original function, right? It's not where, oh, the whole thing is moving up, oh, the whole thing is going to the left, or it's going to the right. You're doing two things. You're changing the shape and you're moving it. That's why you should write out the points first, and then you apply the transformation. Okay?
The points for our parent function. What we're going to do is we're going to apply the appropriate transformations to these points to get points called image points. So we're going to apply the transformations of f at x to get our transformed function g at x. and we'll make a table of values for that function by applying the proper transformations.
Okay, so what we did earlier when we said, K is going to be 2, therefore it's going to be a compression. That is true. But what he's showing you here is to give you the points. How do you actually draw that? Like, how would you draw it, right? So you need to come up with your points from the original function, right? And then you'll see the transformation. So every value here for X, you're going to multiply by 2. That's what's going to be up here. Every value for Y, you're going to subtract 1. Because that's what's the transformation shows, okay?
Then we'll plot those points onto our graph to get the graph of the transformation.
So when you plot the points, then you're going to see it compressed and it moved down, okay?
Function. So first of all, our parameters K is 2. So K value of 2 tells us it's a horizontal compression by a factor.
See, like we said before, horizontal compression by a factor of 1 over 2.
Of 1 over K, so by a factor of 1 over 2. So that's our first transformation. Horizontal compression by a factor of 1/2. So that means what we're going to have to do, horizontally compressed by a factor of 1/2. Well, any horizontal transformation is going to affect the X values, and it's going to be compressed by 1/2. So that means we have to cut all the X values in.
Yeah, so basically every value of X, because it's a factor of 1/2. So X over here, I'm going to divide it by 2. X over here, I'm going to divide it by 2. X over here, I'm divided by 2. X over here, I'm divided by 2. Okay, so let's just go through that quickly with the graph. Right, you can see here, X, because that's the factor, 1 over 2. So that's what you got to do on top of these tables to see what kind of transformation you're doing, okay? With the Y, you're subtracting 1. So all my Y's are subtract 1. Excuse me, guys. Okay, so then when you plot it out, -3 divided by 2 is -1.5. -1 divided by 2 is -1/2. Okay, so I'm just going to go through the graph. You can see, right? All of these values of X are now divided by 2. So that's the factor right there. Okay, now all these values of Y, you're going to subtract 1. There you go. Okay, and now you're going to plot it. And when you plot it, you're going to see it look like it's compressed and it moved down. So let's look at the plot. There you go. You see that? And that is the end there. Okay, so you can see it compressed horizontally, it got squished, and it moved down by 1. Okay, I believe that is the end of that video, and I believe we're done with our lessons. Okay, so there's worksheets here. Let's see, you have also here your tests. I'm just showing you the screen here. Scroll down. Okay, now just a reminder, when you guys are doing the test, please, like I says there, it shows like different sections. You have to submit it in the right section. Do not put everything in one file and submit it only in application and then come and tell me, sir, everything is an application. No, you have 3 different areas. Give me 3 different submissions. Okay, application, a communication, and a thinking. So all your thinking questions, submit it into thinking. All your application questions, submit it into application. Don't mix them around and tell me afterwards, sir, oh, I submitted in the wrong one. If you submit in the wrong one, go back and submit it in the right one. Okay, because I got 40 students. I'm not chasing out which one is submitted. I'll just give you 0. And then if I give you 0 and you say you did it, and you say, oh, I put in the wrong one, well, you can't do that. So please submit it in the right spot. Keeps things organized, and then there's no issues later on for you guys. Okay, these are common problems. I'll give you an example. Somebody will take a picture of their question, and they may label it as, and the questions they did were application. They took a picture of the application, but they forgot. So when they go upload it, they're uploading the wrong image right? And the wrong image they uploaded into communication. So you have to be very double check when you're submitting, it's the right file that you're submitting into the right category. Okay, please do that. You can submit typed if you want to, or written. The only thing is I suggest submitting PDF is the best. Okay, sometimes images, people take images and then I can't open it. I don't know what kind of camera you used, so make it a PDF, please. Okay, make it a PDF. Don't send it as some kind of weird image that I can't open. A PDF is easy. I can actually just see it on the screen and I can mark it on the screen. So if you take a picture, maybe paste it on a Word document and turn that Word document into a PDF. That's the best. But do not just send a picture. PDF is the best way. Okay. Then the other thing too now is the quiz for this lesson we just talked about today. Here's the quiz, Unit 2. Oh, sorry, my bad. Quiz for July 9. Yeah, right here. July 8th. Here's the quiz. It opened up and it's due tomorrow. Or due tonight, I should say. Okay, that's July 8th quiz. Okay, so you have the quiz and you got the test. Okay, so that is it. I'm gonna let you guys go. You got the rest of the day to work on both. Have a good day, and I'll see you tomorrow at the same time. Okay, bye guys.